Hello everyone, today we are going to solve problem 8 of chapter 3. The chord ABC and BD can each support a maximum load of 100 pounds. Determine the maximum weight of the crate and the angle for equilibrium. So in this problem we can see that we have two chords, AB and ABC as well as BD. Because the chord is the same here, the pulley is only changing the angle and not the magnitude of the force. So the tension in chord AB and BC would be the same, but the tension in chord BD would be different. So the problem is asking for theta. So theta is one of the unknown, as well as W, the maximum weight of the crate. So the first step in solving equilibrium problem is to draw the free body diagram. So we want to draw the free body diagram of the pulley. Here is my pulley. I have a tension here, also a tension, as well as TBD. These two are going to be the same, the tension, because we are talking about the same road. So I call it ABC, and I call this TABC. The angle that I have here is theta. I don't know the angle. This one, but I know the angle for TABC. It's just going downward. TABC, I don't have the angle, but I have the dimension here, 5, 12, 13 triangle. So I'm gonna draw this triangle here, 13, 5, and 12. So I need to draw my coordinate system. I'm going to use Cartesian coordinate system. So we know what is x and what is y. And then solve for the unknowns. Because it's equilibrium, we have two equations. Summation of forces in x equals 0 and summation of forces in y equals 0. So we're going to use these are two equations. But looking at the problem, we know that TABC, the tension in this rope, would be equal to the weight of this crate. So these two are going to be W. We could draw a separate free body diagram here and call this, bring it here, and then we have a tension here, and then we have W. That would be TABC. But I directly wrote TABC equals W. If we look at the problem, we see we have three unknowns. TABC, or W, that's one unknown. TBD, that's another unknown. And then theta, that would be our third unknown. And we only have two equations. So we need more information to be able to solve the problem. The problem is saying that the chord can each support a maximum load of 100 pounds. So it doesn't mean that the tension in these ropes are going to be 100. That's the maximum capacity that they could have. And we don't know which one is going to reach that capacity first. So we could assume that TBD is going to reach that 100 pound, and that would be the limiting rope in the maximum load of the crate. So I could replace 100 pound here and see what value I get for TABC. So if I redraw my free body diagram here to make it cleaner, I have 100 pound. I have W, and I have W again. And this would be 5, 12, 13. And this angle would be theta. I'm going to use summation of forces in x and y. So let's start with summation of forces in x equals 0. What component of force do I have? This 100 pound is going to have a component in x. It would be in the opposite direction. So that would be negative 100 cosine theta. And this W is going to have a component. We don't have the angle, but we have the dimension. So that would be 5 over 13 to get the horizontal component. And it's in positive direction of x. So W 5 over 13 equals 0. If I simplify that, 100 cosine theta will give me 513W. That's one equation that I have. I can call it equation 1. I could do summation of forces in y equals 0. Therefore, that gives me 100. This force 100 is going to have a component in y, and that would be sine theta. If positive, is going towards positive y. So 100 sine theta. Both of these forces, W and then the W at this angle, are going to have a component in y. This W is just towards negative y, so simply negative W. And this W, I need to find a vertical component, which would be 12 over 13. So negative W 12 over 13. Its equilibrium, summation of forces, would be equal 0. If I simplify the equation, I will get 100 sine theta take everything on the other side, 25 over 13 W. And that would be my second equation. Looking at these two equations, I have two equations and two unknowns, theta and W, so I could solve for my two unknowns. But the form of the equation makes it simpler if I just divide equation 2 by equation 1. So I get rid of that 100, and then I have sine theta divided by cosine theta, that means tangent theta. And then I could remove W from these two sides as well. So I'm going to write, allow me to create more space here. So here I have tangent theta equals 5. Therefore, theta would get 78.7 degrees. So I divided 100 sine theta, equation 2, by equation 1, and that's what I got, and I found theta. Now if I go to equation 2, so therefore, from equation 2, or we could use equation 1 here to find W, or equation 2, we can put theta in either of the equation. W will be 51 pounds. So we proceeded based on the assumption that this rope is going to get 100 pounds, and then found the tension in the other rope. W is the same as the tension in this rope. So this tension would be less than 100 pounds. So the assumption that we had is correct. So because W is less than 100 pounds, then assumption is correct. The tension in the rope BD will reach 100 first, and that would be the limiting factor. So what if W was more than 100 pounds? If you found W to be more than 100 pounds, that meant that the assumption that we had that this rope is the limiting factor was incorrect, and we have to replace and redo the analysis based on W, or this tension, equal 100, and find the tension here and find the angle.